I would like to come back to the assigning of variables, what we called a name binding, to make it more formal treatment and show the effect of that on functions. The word name binding refers to the association between a name and a value or an object. In Python, we bind name to a value or name to an object. So Python has these concepts, name and value, name and value. When I write line like my str equal string Mustafa, what happens is as following. The first thing is Python is going to create a value in the memory and put the word Mustafa in it. Let's say give it an address 0x111. When you see only this 0x in addresses, it is like what we call a hexadecimal representation. It's just another number for now. The second thing is going to attach the name mystr to the address 0x111, or attach the name mystr to the Mustafa in the memory. Let's create another string and say mystr equals Ziad. The first thing is Ziad will be created in the memory. Let's say at 222. Now mystr already assigned before, so we are going to reattach the mystr to the address of 222. Let's define or assign a new string, another str equal mystr. The another str will be attached to the address of mystr, so now 222. So now another str and mystr both look to the same memory address. If you assigned a third str to Mustafa, which already in the memory at 111, the third str will be attached to 0x111. This is a bit implementation dependent, but anyway, for simplicity for now. Let me show you some visualization for that. In the first step, we said mystr equal Mustafa. So Mustafa is created in the memory values, and we have the names. So mystr is attached to Mustafa. If you are coming from C and C++, you can think of that like a pointer here. So observe, we have values and we have names. In the next step, we assigned mystr to Ziad. Ziad will be created in the memory, and mystr is attached to Ziad. And after that, we defined another str to equal mystr, so another str will be attached to Ziad. Observe, we have two variable names pointing to the same location here, or two names are attached to the same memory value. Finally, we assigned third Mustafa here, so third str will be attached to Mustafa. So this is what we meant by name binding. Binding means attaching or linking. So this name is attached or bounded to this variable. Now going back to functions, I would like to show you some interesting behavior. We have here a global variable x equal 1. In function f1, we say x equal 1. Now what is x? X is local variable because it's assigned inside f, so it's definitely a local variable. No problem in that. In f2, we directly printed x. X now isn't in the local scope, but it is in the global scope. So x would be printed with value 10. In function f3, if you try to print y, you will get an error, name error, because y isn't defined. The troubles start from f4. If you try to print y here, and after it say y equal to, you will not get an name error. You will get an interesting error named unbound local variable. It says that local variable x referenced before assignment. It means your referenced means accessed or printed, for example. You are trying to reference it or use it before assigning. Now wait, why the variable y didn't print? It name error. It isn't defined so far. The point is, remember the local scope. Y is visible within this block, and it seems that y will be assigned soon here. So y is defined already, but it isn't assigned yet. That's why it's going to tell you unbound local error. To understand that, I would like you to, going back here, imagine that y is here, but as in this line y equal 2, we know it's going to be assigned soon. So y as a name is now existing, but it doesn't have an arrow to something. It isn't bounded with something. That's why when you come here, it will not tell you that y is undefined. No, it's actually defined. It exists in the whole function because the scope of it is a function all of it. But at that moment of time, it exists in the names, but it doesn't have an arrow to a value. That's why you get this unbound local error, which means that this variable is visible within the function, but it isn't assigned to something, so you cannot print at this moment. So the difference between F3 and F4 is very critical. We're going now to see some implications for that when it comes to global and local variables. Here, if you try to print x, again you will get the same error. You might say, but x is global variable, but observe, x is assigned inside the function. This is going to mark x as local, so it's going to put it in the names as local variable, and also it isn't attached with a value at the moment. So F5 is exactly the same error as F4. Two cases very similar to F4. The first is saying x equal x plus 1. Now, this is very confusing. You might say x is global, so let's use x equal 10, 10 plus 1, 11, put it local. It doesn't go this way in Python. You have an assignment statement here. So x is going to be marked as local. This is the first step. So x is now in the names, but without a pointer attached to a right side, a value. And now after that you are trying to put the assignment, which is now like x, it doesn't exist. So because x at this moment is now considered as local variable. A very similar, although more confusing, is x plus equal 1. There is a big difference between x plus equal 1 and x equal x plus 1. The x equal x plus 1 is doing like 2 evaluation to the variable x. X plus equal 1 is like doing 1 evaluation. It's a bit more memory efficient style. However, still the binding style of x equal x plus 1 is as same x plus equal 1. Both of them will mark x as local. Both of them will put x in the names without an arrow to a value. If you try to do something like x plus 1 here, it will complain that wait, x doesn't have a value at the moment. Finally, if you decided that let's make x is global, then now this line of code is now is straightforward because x is in the names of the global scope, so no problems here. I know that this might be confusing. Try to think more about it. That's all.